You also recently spoke at GopherCon EU about, what was the subject?
Postgres, yeah.
Postgres. What a great link. Not like an href, I mean like a proper one, radio link.
Like a foreign key.
Oh, nice.
Here we go.
Oh, this is going to be a fun show.
It's going to be either fun or chaotic. Let's find out.
Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at Changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog.
Linode is our cloud server of choice. Grab the Nanode plan for just $5 a month, just $5. That gets you a gig of RAM, a blazing fast 25 gig SSD, and 1 terabyte of transfer. Let's be honest, you can go a long ways on that $5. When you do need to scale up, their prices are predictable, so you can put your calculator down. You won't need it. We've been running changelog.com on Linode for years, and we've always impressed by their award-winning support team. Check them out at linode.com/changelog. Once again, that's linode.com/changelog.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from around the Go community. On next week's episode, Jackie Grindrod and Deshaun Carter join Jon Calhoun to tell the stories of their first week with Go. Subscribe if you haven't at changelog.com/GoTime or your preferred podcast app. You'll find us in all the directories. Right now, we're focusing in on Postgres. Here we go.
Hello and welcome to Go Time. I'm Matt Ryer. Today we're talking about Postgres. I'm joined by regulars Jon Calhoun and Johnny Borsico. Hello, gentlemen.
Hello.
Hey, Matt.
And we're also joined by a special guest. It's Johan Brandhorst. Hello, Johan.
Hello, Matt.
Welcome to the show. I should say welcome back to the show. I notice your Twitter bio says that you are actually a maintainer of quite a few gRPC projects.
Yeah, that's right.
Yeah, so you'll have to come back and do a different show about gRPC sometime.
Oh, I'd love that.
Yeah, we should do that. Aren't you working on gRPC or something? You've just started somewhere.
Yeah, so I just started a new job at a company called Buff, where we're working on stuff related to gRPC, but more specifically around API management and making Protobuf easier to use, basically.
Very cool. A lot of the gRPC repos you have are about making gRPC easier to use, like on the web and things, aren't they?
Yeah, exactly. So there's, especially at the start of the kind of gRPC, when it first came out, it was kind of dropped out of Google, and then obviously you're expected to know as much about it as anyone at Google. So there was a lot of space for blogging and creating example repos for users who weren't so familiar with the packages.
Yes. Great. Well, and you also recently spoke at GopherCon EU about, what was the subject?
Postgres, yeah.
Postgres. What a great link.
Yeah.
And a link. Not like an href, I mean like a proper one, radio link.
Like a foreign key.
Yeah.
Oh, nice.
Here we go.
Oh, this is going to be a fun show.
It's going to be either fun or chaotic. Let's find out. We should maybe start just at the very beginning. For anyone really new to programming, what is Postgres and why would you ever use it?
I guess I can pick that
stop
up.
Stop them.
So
if we've stumped him there, we are going to have a bit of a troublesome show.
I kind of gave a whole introduction about this at the presentation, so I should know. Basically, what I said then was whenever you want to store some data that needs to live beyond the lifetime of your application, you probably want to use a data store. And you can write a disk, for example, you can create a file or whatever, but as soon as you want to do things like filter on the result sets or read concurrently or things like that, everything becomes much easier with a purpose-built application. And Postgres is one such application.
Yeah, that's great. So yeah, saving data, not just dumb saving, like you say, sticking JSON into a text file or something, but slightly more sophisticated things than that. And of course, Postgres has been around a while as well, hasn't it?
Yeah, so it's over 20 years old now, actually. It came out of Berkeley, I think. It was a project that they were working on internally, and then they created an open source project out of it. That's why it's called Postgres. It's the post to something called, I can't remember now. That was a poor lead
That's
on.
all right. It's the post to something called Gress.
Exactly. That's kind of where the name comes from, actually.
Yeah, right. No, it makes sense. So Gress maybe was like a database before it.
Yeah.
Yeah, I mean, we can guess. Next week, we're going to be guessing the origins of the name Rust.
Ooh.
Yeah. Okay, so Postgres then, it's been an option for a while. As you say, it's been around a while. What makes it a particular favorite of yours compared to alternatives? Because there are lots of alternatives.
Indeed.
And MySQLite, for example, is quite an interesting.
SQLite is also another popular database like Postgres. The cool thing about SQLite is that it all works in a single file, but Postgres is a little bit more complicated than that. But the big thing that Postgres has over SQLite in Go specifically is really good library support. So unfortunately, the SQLite driver that everyone uses is a CGO driver. And as most of you probably know, CGO means building with C, it means longer build times, it means less portable binaries and stuff like that. So in Go with Postgres, we actually have several different pure Go libraries to speak with Postgres, which is really great. So that's just one reason to use Postgres. But other things are such as the stability of the software. For example, as you say, it's over 20 years old. It's been used by thousands of companies worldwide. It's not going to just, corrupt your files because those bugs have been ironed out by now. So within databases, I think you often say you don't want to use something that's less than 10 years old because this data needs to live for a long time. You want to make sure it doesn't, corrupt on the disk or whatever. And Postgres is one such stable, mature solution. It's also very fast because it's written in C, and C is fast. Mm-hmm. It's easy to run. You can provide containers for running in the cloud or running it locally. You can also install it locally. You'll be able to install it on basically any operating system that you're running. And many cloud providers have specially built databases like RDS and GCP Cloud's SQL for running Postgres compatible servers. So you can just talk to Postgres anywhere, basically.
Yeah, so because it has a SQL interface, doesn't it, at its root?
Yeah, well, the wire interface is a little bit different from other things. So when I say on the wire, it means like the interface that you're really talking over the network. Mm. Obviously, to the user, it provides a SQL, the structured query language interface, so you can do things like selects and updates and inserts like that. So as a user, it provides a similar interface to other SQL databases that you may have used. But then on the wire, so to speak, it's a little bit different from, for example, MySQL. But actually, Postgres has kind of spawned its own little sub-genre of databases because Postgres is so popular. A lot of other databases implement their wire format in the format of Postgres. So, for example, CockroachDB, which is a large, popular, well-funded startup that's basically taken Postgres and made it more easy to deploy at a very large scale with clustering and geo distribution, for example. That implements the Postgres wire interface so that you can basically pretend that your CockroachDB database is actually a Postgres server, and you can use the normal Postgres, the Go Postgres drivers to work with CockroachDB.
So as a programmer, what's it like to use? Presumably, you create tables at some point, and a table has columns and there's data types and things. Is it that familiar, the sort of spreadsheet kind of mindset? If you imagine a spreadsheet, it's kind of that sort of thing, isn't it? Is it the same for Postgres?
Yeah, so you could say that it has rows and columns, of course. So you can imagine like a matrix where each row is a new entry of data, and each column is a different data type or field in your schema. So it's built on this SQL. I actually prefer to say SQL. That means that you have to define your tables in the SQL language before you start working with the data. So in contrast to something like a document database where you can just take a blob of JSON and insert it and again read it out, when Postgres and other SQL databases like it, you have to predefine the structure of your data. So you will say, I want a table of users, and I want the users to have exactly these fields. And you can only insert data with that structure, and you can know that when you're reading data out of it, it will have that structure. So it's I kind of prefer saying that it's like going from using Python to using Go in that you get that typing included in your data structures.
Yeah, absolutely. There is a kind of nice freedom you get with document stores because it feels like you can just throw anything in and query it and it works. And of course, if there's different shapes of data, that's sort of no problem. In practice, it turns out to be a little bit of a poisoned chalice because often you've just moved the problem. You still need a schema. You still need data structures. They exist. You may not have discovered them up front, but with the technology like Postgres, you do. You have to sort of plan a bit ahead. And so, for example, a table then, if we were modeling a blog and we had blogs and we had posts and then comments, we might have a table for blogs, a table for posts, and a table for comments. And that's because each of those data types looks different. You know, comment might have an author and a timestamp, as actually they all might, you know, but there's other fields might be different. I couldn't think of another example. Yeah, so that gives you this sort of idea. And then they link together by referring to the primary keys in those other tables. I just want to give a very basic kind of overview for anyone that really hasn't had chance yet to play with databases properly.
I think your spreadsheet analogy is a pretty good one for anybody who's never used Postgres or any SQL, database, where you're essentially, you just have to predefine the columns up top, and then you can have multiple sheets that are connected. So like when Matt's talking about, having IDs that link to other tables, it's almost like you have your user's spreadsheet, and in there it might say like, okay, if you want to find this user's purchases or something, you have to go to the purchases spreadsheet and find all the ones where the user ID column has that user ID. So I think that's probably one of the biggest differences between a lot of other types of databases is that in a SQL database, you're generally running queries to join that data, to connect them all. Whereas in a lot of NoSQL databases, you do a lot of that work up front to sort of get whatever format you need it in. And that can be good or bad depending on your situation.
Yeah.
I've heard from people who deal with very large scale that at some point the relational model, be it with MySQL, Postgres, Microsoft Access, I don't care, whatever you want to use.
Yeah.
Microsoft Access, I have nightmares about that stuff. Yeah, so at some point the relational model, they say that it starts to break down, right? I'm curious if one, has any of us on the show here sort of ever reached that sort of theoretical boundary where having a relational model really starts to break down in terms of speed of access, or really like once you start having such complicated business logic that you have the number of tables you're joining starts to create a performance barrier, right? And basically how you sort of go around that.
I can say for me, like I've had cases where very complex queries joining a bunch of different tables caused us to have really slow queries. But almost every time it wasn't that the database couldn't handle it, it's that we were doing something else wrong, or like we had to optimize something else. And like the simplest example of this is if you set up a database and you don't have any indexes, so there's like no sorting of your fields there, and you're looking up users by email address, well, that'll work pretty fine. It'll work well until you have a certain number of users. And then at that point, eventually it's just going to take too long to scan the entire database for all those users. But the way you fix that is you add an index and then all of a sudden that query becomes quick again. And basically my experience now granted, I think there is some upper threshold, but all of my experiences have been that we basically just got into one of those situations where we need to understand the problem better and define indexes or something to simplify it in some way.
Yeah, denormalization is something that comes up when I think about this kind of thing, because often that's a decision that you make really for performance reasons. And with relational databases, they're nice because you can kind of query them in different ways later. You can join in the query itself, make different joins on the data, can't you, to mix data in different and new ways. So that's very nice if you're exploring possibilities with an existing application. If you contrast that to document stores where you're just storing basically JSON blobs, you have to pre-prepare everything in that JSON blob really, or have some tech around it to kind of simulate that. Maybe there's a way when a user changes their profile picture, maybe there's a task that goes back in a document store and updates all the previous times that was copied. And you wouldn't need to do that in a relational database because, of course, you're joining it at the sort of runtime. And that's another time when, at least when I think about this at massive scale, that's why document stores exist, isn't it? It's because at massive scale, that data's probably distributed geographically, and just joining it's not as simple as just reading from one place. That's one of the problems we have with it.
I think that's one of the problems that Cockroach is trying to solve as well. So they used a raft algorithm to have a leader-follower relationship between nodes, so that the data is replicated across different geographical nodes. That's how they try to solve that sort of thing. But yeah, that's definitely one of the problems with Postgres specifically as well. Like, how do you do that sort of data replication otherwise?
I want to pull on that thread a little bit because depending on how much data, right, you're dealing with, it's usually sort of unclear, right? So if you read enough blog posts, read enough content out there, you'll eventually run across advice as well. Once you reach a certain scale, right, the number of, say, read replicas you're going to have, stops being sort of good enough, right? And then, there's various metrics you can use for that. I think it's going to vary from team to team, from domain to domain. Then you're going to see some advice around, well, yes, it's good to store your quote unquote transactional data, right, in a relational store. But if you want to do things like reporting, for example, these kinds of things should live in a separate database, right? Whereby you have a lot more denormalization going on. Maybe you're using a data warehouse, maybe using a different approach to altogether, maybe using star schemas, hybrids, whatever the case may be. But you're really moving away from sort of the use cases. You're splitting the use case whereby you might have an application, which is, this is where your users are sort of using your application and pumping a lot of data in there. And maybe you might have a read replica for the read heavy actions, but for your internal business users, or even for a separate product that relies quite heavily on computation and reads and sort of a reporting, right, creating dashboards and things like that, maybe you want to move that data, right, to a different database system altogether. And I've seen Postgres used in both of those cases, right? You can create your schema, right? To use a common terminology from my data warehousing days, you can create a star schema, also in your relational database, right? It could be a separate user, it can be a separate database, but you can use the same sort of traditional relational databases to actually create those. So I'm curious what sort of our collective experiences have been with regards to how soon do you sort of make that split in your applications, or do you go for as long as you can, right? Saying, hey, you know what? Using Postgres is just fine. I don't need to bring in new tech to do reporting. I can just create another schema inside of my existing server, and I'm good, right? So what is the advice, first of all, with regards to transactional versus pure reporting, sort of OLAP data, versus, do you keep everything in one system? What are the things are you considering, right, before you make that decision?
Wow, that's a big question.
We ask big questions on this show.
Like, I'm very much a if it isn't broke, don't fix it type person, but that's only because it's bitten me so many times to do that. So I very much will stick with Postgres until I'm absolutely certain I cannot solve this problem without it.
When is that for you? What is that?
It just depends is the problem. I've talked to people, in multiple cases, I've heard hundreds of millions of rows works in SQL databases fine. Mm-hmm. But I also know there's some tables where that probably doesn't work because of how much data you're storing or whatever else it is. There could be something weird there. I think it just really depends, on the specific problem, what you're working on. But for me, it basically just came down to if I'm actually seeing, bad performance, then I start looking at, is there a way to fix this within Postgres? Or is it going to be a better long-term solution is sometimes also the thing you look at to switch to something else. So it's really hard to tell somebody when they should do it because it just really depends.
It sounds like you've narrowed it down to just performance though, right?
For me, that's what it's mostly been. Mm-hmm. But it's kind of hard to say because if I could put a little bit of effort into this and get the Postgres to work, that's one option. But if I know it's going to continuously cause more issues down the road for us developers to maintain, then at some point, even if we can get the performance there in Postgres, it might not make sense to stay there if, it's going to cause a lot bigger developer headache over the lifetime of it.
You could always just stick a cache in front of it, and then it doesn't really matter how fast it is at all. You can relax a bit then.
Matt, is your cache also on your database server?
Actually, that's a good point, because sometimes you want to have data ready in a different format. And so sometimes, these queries might be slow running, so you wouldn't do them while a user's waiting in the browser for the answer. But maybe you do it on a schedule, I don't know, and save the results each time, and then they're easier to read. And then I potentially would do that in the same database. They're the sorts of things you do to address performance problems. I think we get a little bit obsessed, don't we, with the performance of individual components. And sometimes when you step back and look at the whole system, it might end up being insignificant compared to other things. We should do an entire episode on caching, because that is its own world of pain. But, very powerful, but kind of not something you have to worry about too much unless you get the sort of big scale. And I think that's the other thing. Most projects stay quite small, and that's why you don't have to worry too much about performance.
Mm-hmm. So along those lines, so when we do have that show, and I'm going to hold you to that, when we do have that show on caching, and I think we do need to have one, I do want us to talk about views, specifically materialized views in database technology, because what I've noticed, it should be no surprise on folks listening to the show, I work for Heroku, and we probably have the largest fleet of Postgres databases, right, for a cloud platform. That's our bread and butter. And we see all kinds of different patterns of usage for Postgres, right? And my single biggest takeaway, right, from my experience there has been that folks underestimate how much power Postgres has, right? They're quick to bring in other technologies, right, to solve certain kinds of problems, right, that they don't necessarily need to, right? So maybe that's being driven by hype. Oh, let me go try Cockroach. Well, why, right? Well, I want to use NoSQL. Well, have you tried to model your domain, right? Have you tried to model your business problem? Like, what kind of data are you dealing with? Is it graph-like? Is it relational in nature? Like, there's a lot of work that is missing, right? Some pre-work that is missing before you make that database technology choice. And if you don't know enough now, right, to make the quote-unquote appropriate choice for your domain, start with the relational model, start with Postgres. You don't have to use Postgres. You can use MySQL if you want, but start with the relational model, because the tooling that exists for relational databases, relational databases have been around for many, many, many years, right? A lot of hard problems have already been solved, right? So the tooling and the domain knowledge, the developer mindshare, all that stuff is there, right? The NoSQL stuff is still, there's wide adoption for it, but there's not nearly as much, right, content on how to solve different kinds of problems, performance problems, right? Operational problems, right? As it is in the relational world, right? So you can start out with Postgres. It's fine, right? And then just like John's saying, you address your performance or scale problem once you reached, right, that point where you can sort of actually pinpoint, right? You can actually see based on metrics, based on your utilization. Hopefully you have monitoring going on. You can kind of see what your performance looks like from day to day, week to week, month to month, right? Then you're making decisions based on data, right? Not on a hunch, not on the latest hype, not on who's, what big famous, tech company is, just published a blog post about using something else instead of Postgres or something like that, right? Base your decision on like what your actual needs are. And I'm curious to hear what Johan has to say about that, because he's been quiet. I don't want you to be quiet.
I was sitting here nodding along to what you were saying there, that start with Postgres, because I think a lot of users come into the space knowing what to use. And that was kind of a hope with my talk, just giving you an introduction to something you can use, some opinionated tips on what libraries to use and so on, giving you like a head start, just getting started with actually like moving away from the problem of choosing a technology and actually using the technology to solve your problems. I really agree with that sentiment that a lot of people will try and Google, what should I use to store my data? Or even like read some popular programmer's blog where they tested out the latest technology and found it to be really good for their very specialized use case, and then apply that to like all of their problems because that's all they know. And, starting with something well-tested, well-established, like you say, good developer mindshare, like Postgres will take you very far before you need to change.
Changelog News is the best way to keep up with the ever-changing world of software. We track, log, and contextualize the coolest projects, the best practices, and the biggest stories each and every week. Make changelog.com your daily destination, or hit the snooze button and subscribe to our weekly newsletter that hits inboxes on Sunday mornings. Join more than 15,000 enthusiastic readers. It'll cost you exactly $0, and you can subscribe right now at changelog.com/weekly.
I think there's also probably the issue that MongoDB is so easy just to throw data at, like Johnny said, without even thinking about what your schema is going to be or what data you're going to have, that I think when people are first learning, sometimes it's easier just to have something you can throw stuff at and not care about. And I think that just sort of sticks because at some point, like if you want to use Postgres or really any SQL database, you have to learn SQL to some degree. And then as you get to more and more complex queries and you get more and more data, you have to learn it even further. And I think some people just don't like that learning curve. Like they just don't like to have to invest into that. But I do think that's often a mistake because like we've talked about all these different uses for SQL, and I've seen so many great cases where you get so much by using a SQL database. One example is like for one company I worked for, our entire metrics dashboard was just a couple SQL queries that you fed into like the graphing software, and it just spit the whole thing out. So like we didn't have to do any work, and we could get pretty much any metric we wanted graphed, and anybody who was on the sales team or wherever could track these things really easily. And that was really powerful because it wasn't like massive developer effort to get them these things they needed. It was, okay, just tell me what you need and I'll write the query for it and you're good. And I think people get worried that, like Johnny said, they think that it's going to cap them somewhere. And I think that they don't realize that more than likely, if it actually caps you, you're at a stage where you can invest in experts like database, people who are specifically, this is what they focus on for their entire career, and they can help you figure out good solutions. And you're going to need somebody like that at that point. But if you're not at that point, you can almost just bring somebody in to consult for like one day who could probably come in there and get your database running 100 times faster than it was just by looking at obvious issues and teaching you how to fix them. And like that sounds like a lot, but it's really not in comparison to like investing in a technology that might not solve your problems and might lead to way worse issues.
Yeah, I think that's great advice. It's the same thing like in JavaScript and Go. Go has that type safety. So if it asks for a string, you can only give it a string and it's enforced by the compiler. A bit like how the table schemas kind of enforcing that schema for the data. And any exceptions to that will be an error, probably. And of course, in JavaScript, if something's asking for a string, you can say, no, here's a photograph of a cat. And that's it. JavaScript will say, okay, cool, thanks. And just carries on.
Hey, when that happens.
Yeah, it's a good point. You don't solve any problems, you're just moving them. That's the thing. So it feels good just throwing stuff in a data store, but at some point you have to read it and use it. And then if it's not in the same schema, you've got even more work to do to figure that mess out, But one of the approaches that I remember when I used to do relational database work in Ruby days were migrations. And I wonder if you can do migrations with Postgres. Migrations are, for anyone that doesn't know, essentially, in order to describe the schema, you run SQL commands. Like you might say, create this table and add these columns and this, add this column that's a string and things like this. And of course, you can use the same kinds of commands to remove things as well. And so migrations are essentially a little script that makes a little change to the database, accompanied by another little script to undo that change. And that allows you to kind of move forwards and backwards through your database schema quite easily. Do migrations exist in Postgres? Is it just something you would build yourself, or are there other tools already that help you do it?
In Postgres, obviously, as you were saying already, Postgres uses SQL. So any migrations that you want to do will have to be done with SQL. And I have a library that I quite like to use, which is called Golang Migrate. Funnily enough, it's probably the first thing that shows up if you try to Google search for it. And basically what that...
That's good SEO right there. That is excellent SEO right there.
Basically, it just has this structure of files where you order your migrations by lexicographically sorted file names. So basically 001, initial schema .up.sql is the first kind of snippet of SQL commands that you want to run when you first start working with the database, which will normally be the thing that creates the tables and sets up any relationships between the tables, and then nothing else. So the more interesting kind of use case for migrations is later on when you decide that, hey, we actually need to add some more information to this table here, but we already have a lot of customers in the table, like we'd have to manually go through and like add the email to all of them or whatever. So a migration script looks at the existing data. You write some SQL to do this, of course. You write some SQL to look at the existing data and then adapt the existing data for the new table details, whatever that you've added with your changes. So that's really the key reason why you need migrations, really. So if you're like a novice user and you find yourself never making any changes to the database, you could probably get away with not using migrations, but I quite like doing it from the start because it means you can very easily pick it up again when you actually need to make those changes. And I often find that you do need to make those changes eventually. And it's also a really nice separation between querying, which is something that you can, there's a few different libraries in Go for querying data that don't actually do anything about creating data or creating tables, and the migration script, which is responsible for setting up and also tearing down the schema itself. So it's kind of a nice separation between the two.
Yeah, and so when you instantiate a new database, it essentially just runs through those migrations in order, right? Applying them one by one, and you know that you'll end up in the same state as your latest release.
So you have to be a little bit careful because often when you have a database, you'll want it to be used by several different clients. And if you do something like an upgrade of the system where you shut down one server and you start up a new server that has like a new feature, so you have both an old server and a new server speaking to the database at the same time, you'll need to make sure that the migrations are being applied in a backwards compatible fashion so that both of those clients can continue to operate at the same time. But if you have a single server and a single database, then it's very easy because you can just apply all the migrations when you start up because you know no one else is talking to the database. That's really the simplest case.
Yeah, it's nice also because you used to be able to try things out and undo them, essentially. I mean, often it's difficult to do. Sometimes you might be making destructive changes. Like if one of your migrations deletes a column, then you're going to lose data. You can't, in the down script, you can't put that data back. But assuming you've kind of thought about it properly, yeah, you could be a bit more experimental with different data schemas. And then you either just don't commit the migrations or you can roll back to a previous version, delete the future ones and try something else. Yeah, it is really cool as a tech. Well, you mentioned the clients in Go. I'm interested from a Go perspective, how do you actually use Postgres? And I'm even thinking like in the context of, say, a website that is hosting a blog, at what point would you make a connection to Postgres? Do you tend to make one connection per instance of your code running and then create sessions off that? Or would each handler make its own connection? How does it actually work, from a Go developer's point of view?
Yeah, so if we take a step back and look at the standard library database SQL package, that actually has a connection pool built in. So if you come from another language like Python or Ruby, you might be familiar with putting something, I think there's a Postgres bouncer or something like that, which does connection pooling between your database and your client. In Go, you don't need to do that sort of thing because it's already built into the standard library. So what you would normally do when you connect to the database is just create a single SQL.db handle, and then that's safe for concurrent use. So you can use that in all of your handlers, even though they're being called from different coroutines from different clients. And you can also configure things such as max connections on the SQL connection. But normally that's all handled by the Go standard library, so you don't really have to worry about it, which is really nice.
So you do use the Go standard library then? Or do you use others, third-party libraries?
It's not very common, actually, but my Postgres driver of choice, Jaxi PGX/PGX, it actually has its own little interface as well for interacting with Postgres, which is a little bit faster because it doesn't have to go through that compatibility layer, so it can structure things a little bit differently. It has a binary encoding that it uses when it talks to Postgres, whereas the database SQL uses a slightly different encoding, as far as I understand. However, I still try to use the standard library just because it's compatible with all of the rest of the Go ecosystem, really. For example, if you have a query builder or some sort of generator to make calls to the database on the SQL.db handle, that's what they expect. And if you're using PGX, then you have the choice of choosing between the two. So, for example, I would use the SQL.db interface as much as possible, because most of the time that performance is going to be absolutely fine for you. But if you do have a specific use case where you find that actually we're being bottlenecked by the standard library here, you can switch to the more efficient binary interface. I would only really consider it if you have to insert thousands of rows or something like that and you want to do it very quickly. Then that's something that you can do with JAXC/PGX. You can switch to the binary encoding interface and do that within a single connection, and then switch back to the standard library one for normal interface handling.
So one of our listeners had actually asked, how hard is the switch from libpq to JAXC/PGX? Because I think historically libpq was like recommended as a library, but I think that one uses CGO, doesn't it?
I don't think so. I think it's pure as well. But I used to use libpq as well back when I started using Go. It hasn't really kept up with the advances that JAXC/PGX has. I think JAXC was later to the stage, but it's really picked up because it has this really rich type package which implements a lot of the Postgres types. So you can work in a Go type safe way with the Postgres types like money and date and things like that. Postgres has really a lot of interesting types that you can take advantage of with JAXC. And then it also has this second interface, which is optimized for speed. It has a really cool way of copying from an interface. So you can give it an interface and then it will kind of call a function on that until it's done. It's like you give it an iterator. So I think JAXC/PGX has innovated a lot in this space in the last 3 or 4 years, which is why it's kind of taken over the crown from libpq.
So I have to confess, I like using the standard library, and some of the things that bother folks, like having to map fields to different different fields from the database over to your Go types and things. Like, I don't find these things annoying as much, but when I do, right, I do like to use SQLX, which is probably one of the early sort of nice little abstraction, nice little wrapper around the standard library database SQL package that sort of made it easy to sort of ingest, say, all your fields into a type all at once, right? As opposed to doing the sort of the scanning and for the different things. So it was for the vast majority of the projects where I'm actually using where I need a relational data store, that I do rely on a combination of the standard library and just a SQLX wrapper. And I have no doubt that libpq, which is I think probably still is by far the most widely used Postgres library within the Go ecosystem. But I have no doubt that it works quite well, and I've used it as well. The new kid on the block, I'm not sure if it's new at this point, like 3 or 4 years old, but I haven't tried it myself. But from what I've read from the documentation, it has some very nice sort of efficiency and performance gains that it has added. It doesn't use the sort of the standard database SQL sort of approach. I guess I don't want to be a wet blanket, right? Like basically always comes as, well, don't jump to the new fangled thing right away kind of thing. So understand sort of your needs first kind of thing. If you're going to pick a driver, that's fine. I'm not saying, use all the different drivers and have different drivers do different things in your application. But again, perhaps that's the right approach, right? So perhaps, just using a standard library in SQLX for the vast majority of your application is good enough. And then in the area where you actually need performance, maybe you're doing, heavy batch processing, maybe you need to, do lots and lots of inserts, and you don't want the index getting in your way for your reads. Maybe you do use, something specialized like that, right? And so to me, all of this comes back to pretty much optimization, right? If you pick something just because you hear it's fast, right, and you're making that decision, well, I'm going to go with that one, right, not knowing why you're going with a particular library, then that's where I'm usually, okay, let's slow down a little bit. Let's understand why using a standard library or like a thin wrapper, right, around a standard library is not good enough for your use case. I have no problem with using the latest and greatest. If you can justify why, you want to use that. At this point in my career, I'm kind of boring. I don't like the exciting stuff, especially as an SRE. I don't want exciting with the things that I'm responsible for. It's really beyond the standard library. Like, what else do you need, right? And can you get away with, using a standard library or something very thin wrapper around that?
A question for you, Johnny. You like using the standard library for it, but I feel like in my experience, Postgres is the one that interacts like the most poorly with the standard library. And more specifically, I'm referring to like last insert ID doesn't work.
Mm.
And then like, I don't remember which ones use which, but like the characters you use for like variables you're putting in.
Dollars, yeah.
I know Postgres uses what, the $sign and then the numbers.
Yep.
And I think all the others use question marks.
Mhm.
So like one of the benefits in my mind of using the standard library is, I can run my tests with SQLite and have it in memory, and that's real nice because I can just throw the whole thing out afterwards. But that's really hard to actually achieve with the standard library unless you put in a like extra work that I generally don't want to put in because I'm like, it's just not fun to do. So like, I guess what are the benefits you see from the standard library from that perspective? And like for somebody who is just getting started with it, do you have any like advice for that, those gotchas?
Let me throw that back at you, right? When was the last time you switched databases? When was the last time you said, you know what, I'm going to start with Postgres, but I might end up with MySQL?
So I've never switched them like in that sense. The only reason that it matters to me is that I like running SQLite for a lot of tests because that means that actually setting things up is a lot simpler. It's not, you need to install Postgres and you need to make sure your database is up and running and you need to do all this stuff. It's literally just, okay, I'm just going to throw this thing in memory and start, I can run all the migrations from that point and have the test go. So it's more of a simplicity type thing there. But I often find that it's hard to actually make work because, all the differences that exist.
Well, I would say that while I see your point, if I knew that I needed to do some integration testing, I need to actually hit, if I don't have enough abstractions around my testing, right, that I need to use a data store and communicate over the wire to a data store, I would just run a Docker version of Postgres. Heck, I have Postgres installed locally on my machine, right? No abstraction layer needed, right? So I think it's just a choice, right? And I think Johan's going to have some flavor to add to that. But personally, like I wouldn't want to use two different databases for my testing, however similar they might be, right? And I know you have a slightly different view on that, but I'm interested in seeing what Johan has to say about that too.
Yeah, so great that you brought up testing because that's one of the things I want to talk about today. And I agree with Johnny that if you have to make your test so that you have to use one flavor of SQL to test and another flavor to run, then, well, to start with, your tests might not be giving you the confidence you want. But also, there is a better solution today, which is that you can use automated Docker testing to create a Docker container during the lifetime of your test and talk to that as if it's a real Postgres. It's a real Postgres container, so you can talk to it like a real Postgres server, and then just shut it down after the test finishes. This was something I demoed during my talk, and I think maybe the most revelatory thing that I'm really brought on to the whole talk, because people afterwards were like, whoa, this is so cool. And yeah, I agree. It is so cool. It like completely revolutionizes the way that you do database testing. You don't really have to like have a Docker Compose script or whatever where you spin up a database, then you run your integration tests with like a build tag on them or something like that, because you don't want to run them if you run Go test, because someone needs to have a database running. And you also don't need to annotate your CI testing with like extra containers, whatever. Everything just works. You just spin up a database. This is during the runtime of your test. It uses the Docker Socket API to just spin up a database, take the IP and port of that database, talk to it during the test, and then shut it down immediately afterwards. And it runs in like 3 seconds total. It's mind-blowing when you see it for the first time. And I highly recommend you try and check it out.
I'll have to check it out because I know one of the reasons I like SQLite stuff is that if I'm running a bunch of tests concurrently, I can have a bunch of them loading up in separate instances of memory and do stuff like that. But I do fully agree that you still need to test against Postgres, which is why, generally speaking, I'd more consider that my like something I'd run in my CI tool. So like, it happens there before it actually goes anywhere, but like I don't have to do it locally as much. And it depends from company to company. I think some of this stems from, coming from a Rails background. I think it was pretty common in Rails to run one flavor of database locally and another one, depending. There were definitely times where that bit you, but it handled a lot of stuff for you sometimes, so you could do it.
So actually, another thing that's kind of related to this is one of my hopes for generics in Go is that the database interface in the standard library is going to get a bit of an overhaul, because I think it's probably one of the weakest typed interfaces in the entire standard library, right? Because you have to, a query, and then you have to give it like a variadic slice of interface, which is as bad as it gets, right? I can't wait to see what we can come up with to make that easier to use. And I think that would also help maybe in this case where we have different sort of placeholders. I guess the dream of the database/SQL standard library package is that you should be able to use it with any SQL database, right? You should just be able to maybe even like at initialization time say, I want placeholders to be question marks, and then everything else should just work, right? As long as you're using, the SQL standard. That's the dream. And I think practically that's probably doesn't work at all. I think if you were trying to write a package that is supposed to be agnostic between different flavors of SQL and different databases, you're going to end up making a lot of compromises that will compromise your type safety, compromise performance, and it's not really there. But I hope that generics could help in that area.
We deserve a better internet, and the Brave team has the recipe for bringing it to us. Start with Google Chrome, keep the extensions, the dev tools, and the rendering engine that make Chrome great. Rip out the Google bits, we don't need them. Mix in ad and tracker blocking by default, quick access to the Tor network for true private browsing, and an opt-in reward system so you can get paid to view privacy-respecting ads, then turn around and use those rewards to support your favorite web creators like us. Download Brave today using the link in the show notes and give tipping a try on changelog.com.
Yeah, I've definitely found, like when you're talking about the performance stuff, Johnny, you mentioned actually just you using the standard library and writing your queries and actually inserting it into whatever field you need to. I've used ORMs and I find them useful in certain scenarios, especially when people don't know SQL that well, as a way to sort of get them a taste for it. But I've also found that even if you're using SQLX, which is really not that much, you tend to write queries that allow you to use their tools to pull the data and, to basically take all the data that you're pulling and putting into a Go struct, rather than writing like the correct query that might require you to do more work, but you're like, I don't want to do that, so I'll run 2 queries instead or something. And like I've noticed that just weird queries like that tend to happen where you almost write bad code because you're trying to leverage a tool a little bit more than just putting in the work to get it done the right way the first time.
That's in my world, at least in my in my mind, ORM is a dirty word. I don't know. I'm generalizing here. Obviously, it has its uses, but I've been part of so many teams where we rely so heavily on ORMs, and they are great for the 80%, right, use case, and then there's that extra 20 where you have sort of trying to twist the ORM so much, and it's not the fault of the ORM, right? It's more like basically we're abusing it, or maybe we're using we're nesting some things, or maybe we're using it in a way it wasn't intended, or it's too easy to make certain common mistakes. We end up creating way too much sort of a thrashing, right, with the database, and you're doing N+1 type queries, and it becomes kind of like a performance issue. And then, often you don't find out about these kinds of problems during testing. You go find out about them in production because locally, typically you have a smaller size data set. You're not querying as much data, or maybe, things tend to be hyper sort of optimized from a performance perspective when you're testing locally, because you don't want sort of data or your querying to impact the speed of your tests and things like that. So you want that quick feedback. But out in staging or in production, where the data volume is much higher, right? You go find out about these kinds of things, right, in that environment. That's never a good look, right? And I always somehow the ORM ends up being sort of the culprit when I start to dive deep into, okay, well, let's troubleshoot this problem. Let's figure out what's causing this problem. And it's because the ORM was allowed sort of the developer to make those kinds of mistakes. So basically, when I talk about sort of using a standard database SQL package, it's not because I believe it's superior to all other approaches. It's because my pendulum has swung from really liking the abstractions of the ORM to basically being bitten by it so many times to basically say, I want to write the actual SQL queries. I want to know everything I'm going to be writing in there, what the interaction is going to be with the database, and I can do an explain plan on it, and I can see see exactly what the cost is going to be in the database server. I can actually see it, right? The same sort of values we hold dear in the Go community, right? That explicitness, right? It might be a little verbose, fine, right? I'm willing to pay that sort of that cognitive cost in order to get that clarity. I know exactly what the query is going to look like on the other side. So yes, ORMs are great, and I think they're great for prototyping. But it's for certain parts of your code base where you really need to sort of keep an eye on performance. Maybe you have a really complex query, lots of things you're joining, and if you can't prove exactly how that's going to perform in production, maybe you write the SQL yourself, right?
For anyone that doesn't know what you're actually talking about, ORMs, can we just illuminate that a little bit?
Yeah.
What does it literally stand for? It's like object relationship.
Relational mapping or model, yeah.
Object relational model or something. I don't know. Mapping? I don't know.
Okay, yeah, something like that. So, but what is it?
So there's a couple different ways you can think about interacting with your database. So ORMs are, you essentially write code in whatever programming language you're in. So let's Go for us. And your database, generally speaking, gets mapped to whatever that code is. And then you write queries in Go code, and that Go code gets mapped to some sort of query in the database. I think at a high level, that's kind of the easiest way to put it.
Right.
So you don't really have to learn SQL. You just write Go code using this library, and it handles all of that for you. Now, the next step that you'll occasionally see is generators, which I think SQL Boiler is one that's popular in Go. Basically, they'll look at your database, and they'll try to generate Go code from the database. Mm-hmm. So they look very similar to ORMs, but they still use the database as sort of the source of truth, and they don't try to translate the other way. Mm-hmm. And then there's the kind of pure use SQL and like translate back and forth yourself approach, which is you have a lot more control that way, so you can fine tune everything. And I should say, Johnny, when you're talking about performance and stuff, I generally view ORMs as a stopgap. Like, you can use them, but you should have the mindset of you might have to replace them at some point, and you should be aware of that potentially being a risk.
Actually, Matt, you may be able to shed some light on this because there are ways, right, to actually write your data access layer, right, in Go otherwise, but we're going to specifically talking about Go here, that would allow you to do what John's talking about, right, to be able to sort of swap out, right, that data access layer, right, with, maybe another data access layer that doesn't use an ORM but uses raw SQL instead, right? Like, what is the approach? What is the recommended approach here? What is the best practice, at least within the Go community, for writing, right, for not sprinkling your SQL all over your code base?
That's a good question.
That's probably my biggest issue with ORMs is anybody who's come from Rails has seen a view that has a SQL query in it. And somebody doesn't realize it's a SQL query because they're just writing Ruby code. But you see that and you're like, why are you running queries inside of a view? Like, that makes no sense. And I think that that's one of the biggest issues you run into with ORMs is that you get what should be database access layer code scattered throughout the rest of your application. So I don't know what your approach is, Matt, but mine is generally to sort of define the few queries I need, or however many there are, and to basically make little services that are like, okay, if I need to, let's say for users, like authenticating, creating accounts, that sort of stuff, I'll sort of define a little struct that has all the methods for that. And then the rest of my code just expects an interface that has those methods. And I pass in, depending on the application, what I pass in will kind of change, but I'll often try to pass in something that's unspecific to the database as I can make it. Now, there are exceptions, like IDs in databases often tend to be integers of some sort, so like that ends up, getting into your code in some sense, but there are other things you can, or maybe not integers, maybe you're using like UUIDs or something, but still, you get some of that in there, but you can still pull a lot of it out.
Don't use auto increment.
Seconded.
Side note, just use your IDs.
Johnny.
Just trust me.
Let me use auto increment.
I don't.
So, Johan, do you use an ORM?
Actually, I have never had the pleasure of using an ORM. So what am I doing on this show talking about databases? I would, very early on in my career, I was kind of persuaded against using an ORM because naturally, as a beginner programmer, I was like, ooh, this looks cool. But I never really had to use it because I was told by someone who knew better than me that that was a bad idea. So here I am, saying to other beginners like myself, once was, that you should try not to use the ORM, even though it looks really appealing at first. You should probably just learn to use SQL, and it's really not that bad, and you'll learn to love it, I think, like I do.
I would agree with that, having come from the other side, because everything specific to Rails that I learned is useless to me now. And everything I learned about SQL along the way when I couldn't get that to work is much more useful to me. And it'll carry over to any language.
That's right.
Well, that would have been an unpopular opinion section, but everyone agrees.
It's not that unpopular, I guess.
It's not happened before where we all agree.
All right. So I have a question for the rest of you. Johnny, earlier you had mentioned that, I forget what you were saying, that when you go to production, you sometimes don't notice performance issues and that sort of thing. Mm-hmm. So, and earlier we talked about migrations and that sort of stuff. So my question is, how do you guys handle testing for things like migrations or things like performance when, generally speaking, you don't have a data set the same as production? Do you have like a nightly type environment or a test environment that clones the database, or do you take other approaches?
We've taken several approaches. The one I've liked the most, and I like it because it was sufficiently complex that we had sort of an elegant way of solving it. And because we were dealing with data, some PII data, right, some personally identifiable information in the system, we had to find a way to effectively sort of not expose, not copy that data, right, into multiple environments. We kind of created a compliance sort of a risk, right? So what we did, but basically, is to basically watch the data. When you have a primary and other sort of replicas, the primary typically needs to sort of communicate, right, changes, right, to those read-only, right, replicas, right? So if you tap into that stream going back and forth, or rather typically going one way, right, from the primary for the where you're writing your data to the read-onlys, if you tap into that stream, right, you will see exactly what the changes are, right? So now we can sort of inject sort of ourselves, or as basically you can think of it as a listener, right? Whereby we can actually see the data, right? And actually keep our a separate sort of test environment up to date with that stream of information, right? And then during that sort of copying over, we actually apply a transformation to that data to remove, right, to anonymize rather the data before it actually gets stored on disk with the test environment. That's an elaborate and more complicated way of doing it, but that's one where it was the most fun for me because, that's when I figured out basically how the sort of the replication and what stuff was working between the primary and then secondary nodes, and basically being able to sort of transform the data sort of in flight and before you write it to disk. I mean, that was like a really fun technical challenge, but that's definitely one of the more complicated ways to do it.
To make sure I understand, so you have like the lead database. I'm so used to bad terms. Sorry. And then you have like the follower. Did you spin up a new follower that you intended to use for test? And then you then when that was popping all the data over to that new follower, that's when you did all the transformations.
Well, it wasn't sort of in the follower sort of pool, right? Basically, the primary wasn't aware of that sort of separate. It's not really a follower. It's just a separate instance somewhere else. Okay. And then basically would be writing sort of that data to it. Obviously, it was a little slower but it was a test environment. It didn't need to be, like a to the millisecond up to date, right? So we could apply our transforms before the data got written. It was a way of actually sort of interjecting ourselves in that process.
Oh, so you kept this going all the time then?
Well, yeah.
Okay.
Yeah.
So it wasn't like a one-time thing. You just like kept it up to date, and then you could use it in the future.
Yeah, kept it up to date as the system changed, and we just kept our staging environment up to date.
It's really clever because if you just read it normally, that would have been activity on the database potentially.
Mm-hmm, exactly. There would have been another client. Yeah.
Yeah, it's funny because we're kind of looking at this exact thing, and it's basically, as Johnny described, what we're going to do is read from one place. I do the anonymizing thing. And what we really want is like the shape of the data. We're not going to read it. We're not going to sit and read through things. So we'll probably scramble everything. We'll probably mix all the words up and everything just so that you don't get, because customer data, if you really care about that, then it's not acceptable to just copy production database to test to work on. Yeah, it doesn't matter really what the data is, but that's really clever though. I love the way that it was like, it must have been some API of a listener API so it could receive the changes. That's a really smart solution.
So another way you can also test migrations specifically is actually kind of write the test where if you have access to the migration files, you can kind of migrate to the first step. You can insert some data. Obviously, it won't be like entirely representative of your production database where you may have hundreds of thousands of customers or whatever, but you insert some data and then you do the migration to the next step and you check that that data was updated correctly. And you can do that for all of your migrations as well, and then run that as a normal test, especially if you spin up a database with the Docker test container. So that's what I've been doing for some of my projects.
In only 3 minutes.
Yeah.
To be fair, I saw that demo that you did, and it didn't look real. It was so quick. Yeah.
I want to say as well, the first time I ran that, I had just formatted my PC. The first time I ran it, I had to pull down the Docker image as well, and it still took 12 seconds in total. But the second time I ran it, it took 3 seconds.
We'll post a link to Docker test in the show notes, dear listener.
Yep.
I need to look at that myself, so...
Yeah, it's good. It's a good point because you want to test as close to that production environment as possible. So,
especially with like migrations and that sort of stuff, if you're doing anything complex, can be really hard because you might have data that you just don't expect to be like in the format it is or something. I know I've definitely had 1 or 2 cases where we're running Rails migrations during a deploy, and all of a sudden something breaks and like everybody just loses it because you're like, I don't know what's happening right now. And it's just hard if you somehow missed it in a test or something. So you have to find good solutions for that.
Yeah, like even the solution that Johnny was proposing may suffer from that issue, right? Because you anonymize the data and all of a sudden you took out all of the like Unicode names or something. I don't know. Like you can never really be sure unless you're doing it straight up against your Postgres database, right?
And production.
That's terrifying, though.
That can't be our advice at the end of the show. Test in production.
Test your data changes in production.
So one last question then. One of the people who was, or somebody on Twitter, I think, had asked, why do we import the underscore for SQL packages?
I think this is left over from not a great design decision in the early days. I don't think anyone would design packages today that used this underscore import thing. Isn't it where there's an init function and it obviously when it's imported, the inits in a package will run, and they can sometimes then interfere. They can import other packages, they can set variables, they can do these kind of magical things in global space.
So use side effect. Yeah, use side effect.
Yeah. And so, yeah.
The worst part is I think all they do is they call like SQL.register and they pass in like a name and then they pass in a driver. I think that's literally the line.
You hope. Well, you hope. Yeah, you hope.
Yeah, you hope that's all they're doing. But like the worst part is I look at it and I'm like, if I had to import this package, I could have just written that line myself and been done with it.
That's right. And I think that was it, though. They wanted... It was before we had a lot of experience with Go, I think. And it was early days where that just wasn't obvious. It seems really quite obvious now in retrospect. And you wouldn't design... Exactly. Probably what you're doing is the same with the image packages. If you want to support GIF and JPEGs and things, you just have to make sure the packages are imported. You don't use them. It's so weird, and I really don't like it. It's no harm to just say, like you say, SQL.register and pass the thing in. It's a bit more verbose. So if you're designing packages, then please do just make it verbose. It's so tempting to want to be very sort of nice and, make it easy, make our users' lives very easy and do everything for them. But yeah, I think that's one example where you don't try and be too clever. Just let them import a package and then use it. And if they don't use it, don't import it. Don't have any side effects to importing a package.
This is one of the cases where ignorance is not bliss.
Yeah. Once you understand how it works, it's still not ideal, but it's not as terrifying. But I completely understand the first time anybody sees it, they're like, look, there's magic in Go. And I'm like, not really. But just requires you, like it forces you to learn about init, which in some ways I'm like, we don't really want to teach people about this.
Yeah. Stay away from globals, generally speaking. Stay away from init.
Yeah.
Is it time for unpopular opinion, though? I mean, I want an unpopular opinion from Johan.
I can do that, actually.
Okay, well, then let's do it.
I could do an unpopular opinion, okay? Boom, boom, boom.
Nice.
I actually think you should probably leave.
I have this library that I like to use, which is called a Squirrel, and it's a query builder, and it uses the builder pattern. Everyone hates the builder pattern in Go, right? And for good reason, because the builder pattern doesn't work well with the static typing that Go provides, because we don't have generics. And Squirrel suffers from this problem as well, but it's also provides a lot of power at the same time. So it's like the one exception to the rule of don't use the builder pattern anywhere is for query building, use the Squirrel package because it's really easy to use and constructing queries with.
So the builder package then, just for anyone not familiar, this is where you get these fluent APIs where every method returns the main object itself and then lets you chain them. Yeah, right.
And I should say I hate these because you can't define interfaces that work with them like at all. It's just a nightmare. So I do have one question, Johan. Could you reconstruct the Squirrel package using like functional options?
Potentially.
Because I'm pretty I've looked at Gorm, which is a big ORM for Go, and I'm pretty sure you could rewrite a vast majority of it using that. I just don't think that was as popular when those libraries were written.
You're right that it's annoying to use because you can't construct an interface that works with it. In the cases where I have been using it, it's usually just like in a single API layer. You're just using it through that package, and you don't really have to pass it around in any kind of generic way. And also, actually, Squirrel does provide a few interfaces for working with the standard library. So it has like a base runner or whatever, an interface that describes how SQL.rows behaves so that you can operate on that and pass that through functions if you want to. I find that the kind of one exception to this rule, but generally the builder pattern and, like Matt described it, fluent interfaces like that just don't work very well in Go. That's my unpopular opinion.
It is a bit unpopular because I don't know that I would agree. I'm just looking at the syntax. You're sort of writing strongly typed code, so there's that, right? Because obviously, if the alternative is just a SQL string, I assume, but you lose that SQL-ness, don't you? It doesn't say select star from table. You lose that a little bit, but you do get type safety.
The reason I ask about the functional options one is that if everything returns the same object, that means that every option function is essentially just going to be a function that accepts that one argument. And then you can just list a bunch of them as things you're passing into squirrel.query, and then you pass in all your options for it. I think that's the type of library that probably could be rewritten like that, and it might work a little bit easier in some ways. I'm not positive.
Me too.
Be a good exercise. I'd like to see you try that, John. Yeah. Live on Twitch.
Well, I've done it with Gorm a little bit. Not the whole thing, because that would just take forever, but I've definitely toyed with doing some of it. So I know the hard part is there might be some weird edge case I don't know about. And that's you almost have to do the entire thing exhaustively to see if it works.
Yeah. We're talking about these abstractions and things. We have in Pace a very light abstraction over the data store, and it's a schemaless document store. So the get and the put operations are abstracted in this kind of a really light way. But what it allows us to do is check, because it's a remote service, sometimes that can fail with temporary errors. So what we can do in that abstraction is check if there was just a network error, just try again. And then you get a kind of robustness for free. And again, a bit like the example earlier of using SQL most of the time, and then you can break that rule and use different ones. I think that is quite a nice way to do it. Use the abstraction. It's not going to be 100%, but use it for the 80% of the cases, and then you can do something perhaps more in depth after, in those cases when you really need it. So yeah, I like that. I've definitely got a lot to think about for this. Just one last question then, Johan. One of the nice things about these kinds of builder tools and packages is that you protect against some security considerations like SQL injection or SQL injection is one. This is what you're talking about, using question marks and dollar symbols for parameters. It's instead of just building strings up yourself, isn't it? Why is that important?
The danger of SQL injection is that you provide some sort of user input that maybe prematurely interrupt your SQL statement and then construct its own SQL statement, and in such a way could make changes in the database or extract data from the database in a very dangerous way. And the way that you protect against that sort of thing is by using these placeholders or extrapolated variables, but they have many different names. Anyway, the way that Squirrel makes this easier is by, like, when you normally use the Go standard library database /SQL interface, you may be tempted to just use a fmt.sprintf to construct your queries. This is kind of the major danger where you might end up causing an SQL injection without thinking about it. If you've ever found yourself, I don't really want to write out this very long SQL query, I don't want to have to map the names myself, I'll just use a format sprintf in a helper package somewhere, and then accidentally you may have gotten the argument wrong or something like that, and you ended up with something that the user can manipulate inside of your query, then that's super dangerous. And a sure way to just avoid that sort of thing altogether is to use Squirrel, because all of the variables that you put into the builder automatically become escaped in extrapolated variables. No, interpolated.
I need to ask, have you met Bobby Tables?
I have met Bobby Tables. This is a great one, actually. So the reference that Johnny's making there is to an XKCD comic, which has a very illustrative way of showing just exactly what SQL injection means, where there's a school principal who's making a call to a concerned parent, I suppose, asking about their son Bobby Tables -- drop tables students or something like that. The parent says, yes, we call him Bobby Tables. And then the principal says, well, I hope you're happy we've lost this year's student records. Which is really funny, because obviously the implication there is that they had to enter their kid's name somewhere in some sort of form or something, and they thought, hey, it would be fun to see if this is vulnerable to SQL injection. And then they put in a command that would, if it was vulnerable to SQL injection, drop the table called students. And of course, the joke then is that it actually did, and the principal is furious about it. And the kind of lesson, I guess, is that you shouldn't have been vulnerable to SQL injection.
Now he's got no job, though, so that's no good telling him that, is there? His life's devastated by that. But yeah, I did start telling a story once, and we had Filippo, a security engineer on the Go team, actually, just stopped me halfway and said, just don't tell that story. It was a similar kind of story about SQL injection, and a good lesson for all. Yeah, he stopped me telling it, which is a good, but if you see me in the real world, I'll tell you my little story about SQL injection. Yeah, but don't worry, kids, you won't be SQL injected. I don't know what that means. I was going to say, don't worry, that bit will be good.
That didn't come out right.
No. What I was going to say is, don't worry if you use if you use it the right way. It's not something to be scared of if you use Squirrel and things.
You're going to have to change the rating for the podcast now, Matt.
I'm just going to make a quick note of the timestamp that I said that at for editing purposes.
It's like PG up until the 58-minute mark, and then nope.
Yep. That's actually how we should do the podcast. It should be an hour, and then there's an alarm goes off, and then it's like the purge. We can just say whatever we want.
It's the watershed in the UK.
If your kids are in the car, you need to close their ears.
Yeah.
Awesome.
Yeah. Well, this was a great show. Thank you so much. It was great to learn so much about Postgres. I think it's nice for junior people to know as well that it's a perfectly reasonable choice. Pick it up, get going with it, learn it, see what you can do with it, see what you can build. Thank you so much to our special guest, Johan Brandhorst, and Johnny Borsico and Jon Calhoun were here also. We will see you next time on Go Time. Goodbye.
If you like Go Time, odds are you'll enjoy practical AI, brain science, and even, dare I say it, JS Party.
Good news, everyone!
You do not have to subscribe to each of those shows individually. Just point your favorite podcast app to our master feed of all Changelog podcasts. It's your one-stop shop for everything we produce. Check it out at changelog.com/master or by searching Changelog Master in Apple Podcasts, Spotify, etc. You'll find it. Thanks again to Johan Brandhorst for joining the gang on this episode, to Matt, John, and Johnny for hosting, and to you for listening. We appreciate you. Changelog's music is produced by the mysterious Breakmaster Cylinder, and we are supported by awesome people at companies who get it. Thanks again to Fastly, Linode, and Rollbar for supporting Go Time. That's all for now. We'll talk to you again next week.
And it's Johan, not Johan.
Johan?
Han
Yeah,
Solo, you know
it
what I mean?
depends where you are. To be honest, Johan works.
You prefer Johan?
No,
How do you say it?
no, Johan. I think.
You think?
Yeah, you don't know, do you? You don't really say your own name.
No, I don't.
When do you need to say your own
Exactly.
name?
When your mom is mad at you, what does she yell?
That's a different question because my mom's Swedish, and in Sweden we would say you won.
You
But in English, no one gets that. Like no one with an English background will get that right, unfortunately, and it sounds butchered no matter how much they try.
It's actually you won something.
Yeah. It's like the Irish Ewan, like Ewan McGregor.
Ewan,
It's kind of,
right.
So if we want to properly introduce you, we have to call your mom up, record her saying it,
Yeah.
Ewan.
slip that in there.
Hold on, why is your name different when you're in trouble?
Yeah.
Your name's change in Sweden if you get in trouble. It's like
Oh,
it's like a goodie and it's like good cop, bad cop kind of thing. I don't know. I just want to learn.
We should have another episode about that.
Why? Why not both? We can do both very well.
Yeah. Oh, well, okay. Okay, hint taken. Drop it. Don't mention it. Okay, fair play. I'll take a hint and then I won't mention it again. That's me. You can rely on me for that.
I feel like Matt's making me lie today. I'm like, we're talking about Postgres and Go and it's like, no, we're not. We're not talking about that at all right now.
We should though. That would be good if we could.
All right, is everybody recording locally?